Alright, in this video I'm going to show how we can build a simple arpeggiator device in Reaktor. And I'm going to begin by creating a clock macro that we can use to run a sequencer device. To run the clock, I'm going to use the control rate output of the system info module. Now the control rate module will output an event at the control rate, which I currently have set to 400 Hertz. And we can translate from Hertz to milliseconds by dividing 1000 over the value in Hertz. And then we can run that value into an accumulator module to keep track of the amount of time that has passed since the last time that we've received a MIDI gate, and we can implement that simply by setting the accumulator to 0 on a new gate, like so. Alright, so now we want to take this time in milliseconds that we have and translate it into a position to read from the sequencer. And we're going to do that by using a modulo module. And we're going to modulo against the length of each step in the sequence. So now the div output will tell us how many steps we've gone through in the sequence, and we want to send that value through a step filter to stop it from sending the same value over and over again. Alright, so now we need to supply the B input of the modulo device with a value, and we're going to start by adding a tempo info modulo. And we can translate the output of the tempo info, which is in Hertz, into milliseconds by dividing 1000 over the value again. And that's going to give us the length of a single note. And I'm going to multiply that by 4. And then the output of this multiplication is going to be the length of 1 bar in milliseconds. So now I'm going to multiply this length of 1 bar in milliseconds by another value to give us our tempo synced sequence length. So I'm going to start by adding a selector and multiplying the output of the selector by our bar length. Okay, so now we just need to supply the inputs of the selector with some values. And, for example, if we give it a 1, then we'll multiply the length of 1 bar in milliseconds by 1, and we'll have a step time of 1 bar. And then to add any other value that you'd like, you can, divide 1 over 2, for example, and then that'll give us the length in half a bar. And I'll just make a bunch of really standard tempo sync times here, such as 3/8, which you can get by, of course, dividing 3 over 8, and on down the line. So this is a quick and simple way to give us a bunch of different options for tempo sync times. So to get any tempo sync time, we simply supply the length in bars that you want to sync by and put that value into the selector. And once we're done with this, we're going to create, of course, a position knob for the selector, but the value of the selector knob is not going to give us as users any useful information about what tempo speed we're using. So I'm going to create a multi-text module as well that we can use to display what our tempo sync value is. I'm going to append it 8 times, so we have 8 values. And then I'll list each time in the appropriate position, like so. And I'm just speeding the video up here so you don't have to watch me doing this for 5 minutes. And finally, let's just put all of this into its own macro so we can keep our whole structure a little cleaner. Alright, so now we can create a multiplex 16 module that we can use to store the values of our sequence. And we'll create a length knob that we'll also use to control the length of our sequence. And then I'm going to use this step sequencer to control the modulation of our pitch. So I'm going to give it all of the knobs a range from -36 to +36. And then go through the tedious task of adding all 16 knobs and naming them appropriately. And since this module takes up an awful lot of space, I'm going to store it inside its own macro, but we're going to keep the length knob outside of the macro because we're going to use it to control several different sequence lengths. So we'll need an input for the length as well. And of course we need to connect the output of the multiplex to the output of the macro as well. And there's an awful lot of downtime and boring tasks in making this project. I'll try to speed them up as much as possible. Alright, so we have our first sequencer completed, and as I mentioned, that's gonna modulate the pitch. And we want to create two more sequencers, one for gate and another for gate tie. And what the tie will do is determine whether or not a new gate is triggered when the gate is on. And for those, I'm going to use buttons. So I'm going to speed up the video here and save you the agony of watching me add and rename 16 buttons in real time. And once we're done with this structure, we can duplicate it to create the tie sequence as well. Alright, so the next little bit I'd like to add on our project is a position indicator that will let us know which step of the sequence is currently active. And I'm going to use an XY module to draw this. And I'm simply going to make it a long, thin shape at the bottom of the sequence, and we'll create a little box that will light up at the appropriate location. And the reason why I like to use the XY module for this instead of a lamp module or something is that the XY is polyphonic, so we can display the position of several sequences simultaneously. So I'm going to modulo the position by the length of the sequence, and we're going to add 0.1 and 0.9 to the output, and we're going to divide the values that we get from that by 16. And this is going to give us a simple bar at the X these are going to be used for the X locations of our bar. And then the Y location will be a 0 for Y1, and Y2 will be equal to 1 if the gate is on and 0 if the gate is off. So we can create that effect using a compare module very easily. And that's pretty much it for the marker, but let's change the look of it real quick and rearrange our panel. And I did a bunch of rearranging of the panel already off screen, so you wouldn't have to watch me do it. But now we're going to make the XY into the proper shape. And so we'll give it a height of 12 and long length. Let's start with 600. I guess it needs to be a little more. Alright, so now if I press a note, And turn the speed up a little, we can watch the position. Okay, so let's go about finally using the values that we're reading from our multiplex modules to control the pitch and gate of an oscillator. And we need to take care to read the sequencers in the proper order. I'm going to read from the tie first, the gate second, and the pitch mod third. And that's because we're going to use the values from the tie and the gate sequencers to decide what happens with the pitch. So I'm going to use a logic AND module for the output of the tie and gate, and I'm going to use that to control a router. I'm going to use the NOT output of that to control a router. So basically this means if the tie and the gate are both on, then we won't pass the value to the output, and otherwise we will. And finally, if the gate is on, we can also send out the pitch. So that sums it up for the arpeggiator part of this project. Now I'm just going to build a very quick structure that demonstrates how you can link this to control an oscillator. So let's start with a note pitch module and a gate module, and we're going to add the output of the pitch to the pitch module, and we're going to multiply the gate output by the gate module. And that way, whenever the gate output is 0, the gate will be 0 as well. And then we can use the outputs from these two math modules to control a gate and an oscillator. And if you wanted to be able to turn off the arpeggiator, you could simply have a switch between the add and multiply modules and the output of the macro. Alright, so let's take a listen to what it does.